All right, so fundamental theorem of algebra will actually state how many possible answers we have, okay, just by knowing the degree. So the degree of the polynomial will tell us how many roots we have, both real and imaginary. Okay. All right, so for example, this degree is 4. So that means I have 4 roots total. Okay. Now, how many real roots do I have? I have 4 or 2 or 0 real roots. Okay, which means conversely, I have 0 or 2 or 4 imaginary roots. So I could use some of this stuff to blind it down. Now, I don't want to use a calculator on here because I want to show you how they used to do it back in the day. Okay, so I'm going to use the rational root theorem. Well, I will probably use René Descartes' rule of sign change first to tell you how many positive roots they have. Okay, so by using René Descartes' rule of sign change, I'm going to see none here, 1 here, none, none. So I have a possibility of 1 possible positive real root. Okay. All right. So I don't have to, in my rational root theorem, I don't have to test everything. Now I'm going to plug in negative x. Okay, if I plug in negative x into a positive exponent or a even exponent, it's going to stay positive. So this is still x to the 4th. The next one's going to be negative x cubed. The next one's going to stay as negative 7x squared. The next one's going to turn into positive 9x. And the last one's still going to be minus 18. So I plugged in my negative 1. Okay, so this will tell us how many possible negative real roots. So from here to here, that's a sign change, so that's 1. Here to here, none. Here to here, another 1, so that's 2. From here to here, that's 3. Okay, so I could have 3 or 1 possible negative real root. Okay? All right, so that will help eliminate some stuff. Now, here's the cool thing. If I find a positive real root, I don't need to test any of the other positive numbers because I know it's going to be impossible because René Descartes' rule of sign change. So plus or minus 18, I'm going to write out all the factors of the last one. Remember, I'm going to do the rational root theorem, so I'm going to divide this by this term, so that's going to be a plus or minus 1 up top. So if I'm dividing by plus or minus 1, I just might as well write the factors of 18. So it's going to be plus or minus 18, plus or minus 9, plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Okay, so those are all my possible factors. Okay, so what do I do with this situation? Okay, so that's 12 possible answers. So if I check 3 of them and I get them to be that way, I know that at least, well, here's an interesting thing. I know that there's 4 roots total. Okay, there could be 4 or 2 or 0 real roots. There could be 0, 2, or 4 imaginary. Okay, so I've got to eliminate that. So I don't have to test more than 4 numbers if I get those 4 right on this. So what I'm going to do is I'm going to set it up. And I think we're going to test out some. Let's go with possible positive. So let's try out with 1. Let's see if we get it. So we write the coefficients of the numbers. So 1 in front of x to the 4th, 1 in front of x cubed. Then we have our negative 7. Then we have our negative 9. And then we have our negative 18. Okay, something tells me this won't work, but at least we'll try. Okay, so 1 times 1 is 1. Add the 1, we get 2. 1 times 2 is 2, so this is 2, so this becomes negative 5. This becomes negative 5. This becomes negative 14. Okay, and this becomes negative 14, and that turns out to not work. Alright, so let's get rid of that. Get rid of that. Get rid of that. Get rid of that. Okay, so that definitely did not work. Okay, so that's huge that that did not work. We at least eliminated one, and that's the important thing of understanding how important a graphing calculator is into this process, because it shortens it up drastically. All right, let's make a negative. So this becomes negative 1, this becomes 0. Okay, this still becomes 0, that becomes negative 7. Okay, this becomes positive 7. This becomes negative 2, and I don't think if I times that by negative 1 that that's going to work either. Oops. Oh well, I'll put it right back. Okay, so I mean it's just a process that takes time. Okay, so we definitely know no to this. Okay, so now that we know that, we try out another number combination. And I think we will try negative 3. Well, let's try positive 3. Okay, so we try 3. So we multiply, we get 3. This becomes 4. This becomes 12. This becomes 5. This becomes 15. Oh, sorry. Okay, 1, 2. Nope, that becomes 15. And this becomes 6. Oh, and there we go. That looks to be it. That's our magic number, 18. So that gets a 0 that we can work it down to. Okay, so now that we know that that works, okay, here's another cool thing. We know there's just one possible positive real root. We found it. So on these other ones, we will not test the positive versions. We will test the negative versions. We already know positive 3 works. Okay, so what we can do later is we can also test out another number, see if it works, and just work it that way. Okay, so let's try negative 3. We seem to strike luck with that. Okay. All right, so let's try it again. We'll get negative 3 here. So we get negative 2. We times by negative 3, we get 6. This should get us negative 1. Okay. This should give us 3. Look at that. That's looking pretty good. Negative 6. And negative 6 times negative 3 is 18. So that works out pretty well. Okay. So I actually get that stuff down. Now the reason I'm going to stop after this is I know there's at least one positive negative real root. There could be 3, and then that would be a total of 4 for a total of 4 reals. But I'm actually just going to do the factoring here and just show you just how this works. Okay, so let me get rid of this. Oh, stupid thing. Let's get rid of that. There we go. Okay. So what I'm going to do is I'm going to go back to the first one. Now this I'm going to start with again. I'm going to start from here, here. And so this becomes 1, 4, 5, 6. And I'm going to do synthetic division with that because I know that's going to be easily factorable out. So I get the 1 down here. This becomes a negative 3. This becomes 1. This becomes a negative 3. This becomes a 2. And this becomes a negative 6, which I knew was going to happen, so it's going to become 0. Okay, so what I've done is I've transformed this into this. Okay, and I'm going to rewrite these two as terms of x plus 3, x minus 3. Okay, so that's going to be from these two. So this is this one, and this is this one. Okay, now the next term is going to be these parts right here. And so it's going to be x squared. Since I've done it twice, I've gone down from the power of 2 to the power of from the power of 4 to the power of 2. And this is x squared plus x plus 2. And I'm going to be able to factor that. Well, if you notice, that's not a perfect square trinomial, nor do I know two numbers that multiply to 2 but add up to 1. So I'm probably going to have to do the quadratic formula. So negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 1 times 2, which is 8. Okay, and it's all over 2a, which is just 2. Okay, well, if you notice, this is going to be a negative 7, and doing a square root of a negative 7 never helps. Okay. All right, so I actually have my answer here. I have these two parts right here. I know the factored form is this. That's as far as I can go with factoring. However, my answers are going to be this, my roots, and then this as well. So this will turn into negative 1 plus or minus the square root, or no, I square root of 7. Okay? I'm just going to factor, because not factor, but I'm going to square root negative 7 to be I root 7. Okay, all over 2. All right, now does that match everything I did? Yep. I had one possible negative real root, which makes sense. I had one possible positive real root, which makes sense. And I had two reals, which was the 3 and the negative 3. And I also had two imaginary, which were these two. Oh, sorry. Those two, the plus or minus version. Okay? All right. So that's how you actually do it. Now, honestly, I don't expect you to test out every rational root theorem. I just wanted you to see where it comes from, okay? Just where it's going to. All right, so what you would do is you would actually graph it. X to the 4th plus x cubed minus 7x squared minus 9x minus 18. Okay, so you would actually graph it like that. And then you would just check to see, oh, which number should I start with? 3 and negative 3. And then what you would do is you would go and do your synthetic division and break it down. These would be your first two steps. And then you would pick up from here. You don't have to do all this other stuff. All this other stuff is I'm just showing you how you can check your work and just to make sure you're doing the right thing. Okay, and actually it was used by the Tartaglias and many other mathematicians for 400 to 500 years. So it's got some legs to it in terms of theorems that have been used a lot. But you can actually just go ahead and start here after you do it. You don't have to start here when using graphing and stuff. That's what I'm saying. Okay, and that's all thanks to the fundamental theorem of algebra, is that you can actually solve something like this and make it your job a whole lot easier. All right, that's it for solving polynomials, and you can do pretty much any polynomial from here on out. I highly recommend get it down to a quadratic and then work with it from there. Okay, thank you very much and have a great day. Bye.